Alright, so as you can see here, I'm using a plain paper because I want to solve as many questions as possible. So we can see I'm going to start with question 3a. So the question reads, by changing the variable, determine the integral of x and then x plus 3 to the power 3. So by changing variable, let me write changing variable on top. So changing so by changing of variables, so how you do this by changing of variables is straightforward. So you first take one of your functions which have been given to integrate, and then equate them to u. In other words, changing of variables is called u substitution. Now how do you do that? So in this case, I'm going to get this part here. I'm going to get this part and equate it to u. So I'm going to have x plus 3. So in short, I'm going to say let u be equal to x plus 3. So immediately after doing this, I'm supposed to replace this part with u. So meaning in this integral, where there is u, I'm going to put where there's x plus 3, I'm going to put u. So now imagine that I've replaced u there. What of this x? Because I'm going to remain with this x again. So in order to take care of this x as well, I'm going to make x the subject in this formula. So I'm going to have x being equal to u minus 3. So that where there is x, I'm going to put u minus 3. And then apart from that, I should also find the derivative of this function. So I'm going to find the derivative of this function, which is going to be du dx. So du dx is just going to be 1. So when I cross multiply there, you can see that my dx will be nothing but equal to du. So here, having done this, it is now very easy for us to find the integral of this question here. So how do we do it? So like I said, where there's x, you replace with this part, and then where there's x plus 3, I'm going to put u. So in other words, I'm going to have my equation looking like this. Where there's x, I'll put u minus 3, and then I'm going to multiply this by u. And of course this u is raised to power 3. Where there is x plus 3, I've just replaced with u. And then where there is dx, it means that I can put du there. So this one is now even easier to integrate, because I know that I can simplify this. U to the power 3 times u, I'm going to have u to the power 4. And then here I'm going to have minus 3u to the power 3. So I'm going to integrate this with respect to u, like that. And then apart from that, so we proceed now by integrating this. So how do we integrate this? So u to the power 4, when you integrate them, you're going to have u to the power 5 over 5, because we just add 1 to the power there, and then divide by the original function, the original power there. So what you're going to have, even on the second one, we add 1 to 3, we're going to have 3, and then u 1 plus 3, you're going to get 4, and then divide by the new power there. Then of course don't forget to put c. Then apart from that, it is also important for you now to take care of this u. Remember, what we are finding is the integral of that with respect to x. So but when you look at this solution that we found here, has u instead of x, meaning where there is u, I'm going to replace back with x plus 3. So I'm going to have something like this. Where there is u, I'm putting x plus 3 raised to power 5, then everything divided by 5, minus 3, and then I'm going to have x plus 3 raised to power 5, and then everything divided by 4, and then plus c. So this will now be my final answer. So this is going to be my final answer. So let's quickly move on to B. So I'm going to demarcate this so that I don't interfere with these solutions. Oh yeah. So let's now move on to B. So my B, our B there is saying integrate x, then we have x minus 1 there, and then we have dx. So what you do here again, you just equate this in under the root to u. So you say let u be equal to x minus 1. Then quickly you make x the subject there. X is going to be u plus 1. And then apart from that, you also make sure that you find the derivative of that. So du dx is going to be equal to 1 as well. So meaning our du will just be equal to dx. So meaning where there's dx, I can replace with du, there's no problem. So what I do here now is I'll find the integral. Where there's x, I'm putting u plus 1. So this x is going to be replaced by u plus 1. U plus 1, and then in brackets like that, then open brackets, I'm going to have the root of, instead of writing x minus 1, I'm going to put u here. Yeah. So what I'll do, where there's dx, I'm putting du. So this one, in other ways, it can also be written as the integral of u plus 1, and then this u can be written as u to the power half du. Then we multiply this, meaning we're going to have the integral of u raised to power 3 over 2, and then plus u raised to power half. So we're integrating this with respect to u, because you put it in brackets like that. So the integral of this is now straightforward. We can just add 1 to the power there, then divide by the new power. So this is going to give us, actually I'm not even supposed to write this now, I'm just going to write equals. And then when I integrate that, I'm going to have u raised to power 3 over 2 plus 1 is going to give me 5 over 2. And then you divide by the new power, which is 5 over 2. Then you proceed by saying plus, and then u half plus 1 there, you get 3 over 2 as your solution, and then you divide by 3 over 2, and then plus the constant there. So from there you can now replace where there's u, or you can simplify it further by saying this divide by that, you're going to have 2 over 5 u raised to power 5 over 2, and then you have plus 2 over 3 raised to power, and then u raised to power 3 over 2, then plus c. So how do you finish up this? So this one can also be written as 2 over 5, c is 5 here, and then this u can just be written as to the root of u and then raised to power 5. Then you're going to have 2 over 3. So this is also going to be the root of u in brackets like that, raised to power 3, and then plus c. So it's in the same way we did this. Where there is u, we're going to replace with x minus 1. So in short, the solution is going to look like this. Let me just do this. So my integral of x root x minus 1 dx will now just be equal to this will give me 2 over 5. Then where there's u, I'm putting x minus 1 raised to power 5, then plus we have 2 over 3. Where there is u, we put the root of x minus 1. then in brackets like that, the power 3 plus c. So this will now be your final answer. This will now be your final answer. We can proceed to the third question, which is C. So C is saying the integral over, let me just write it here. So this is C, is saying the integral of x over x minus 1, x over x minus 1, sorry, x over the root of x minus 1. So in the same way that we did the previous question, this is the same way that you do this question as well. So first of all, I'll equate this to u. So I'll say let u be equal to x minus 1. So meaning I'll make my x the subject there, meaning it will be u plus 1. And then what else? So here where there's x minus 1, I'll put u, and then where there's x, I'll put u plus 1. So I should also find the derivative of this one, which gives me 1. So meaning my du is equal to dx. So the other thing here that we do now is just to replace everything in that expression. So x, where there's x, I'm putting u plus 1, and then where there's the root of so this will now be the root of u, and then this side we are going to have du like that. So here it's just a matter of here it's now just a matter of integrating this. So how do we do that? I know that this can also be written as u plus 1 over u to the power half du. I know that this can also be written now as u plus 1 over over 1 times u to the power negative half, and then du. So when I multiply this, I'm going to have u times u to the power negative half. I'm just going to add the powers since the bases are the same. So when I add 1 plus negative half, I'm going to get positive half, then plus u to the power negative half when I multiply this times 1. So du, of course this is supposed to be in brackets. So here what you do again is it's just a matter of integrating this now. So when we integrate this, we're going to have, let me just write equals now. So when we integrate this, we're going to just add 1 to the power there. So we're going to have half plus 1, you're going to get u to the power 3 over 2, then over 3 over 2 like that. And then you write like that, then plus u to the power half over half like that, and then plus our constant c. So this can also be written now as, you can see that we can write that as and this can just be the root of u, and then we're multiplying this by 2 over 3. This is supposed to be like this. I'm just trying to write this in another form. So we can see that that is plus, then we have 2 the root of 2 the root of u, and then plus c. So let me just demarcate this. Okay, and then here now it's just a matter of replacing where there is u, we put our x minus 1. So the final answer will now be equal to 2 over 3, and then the root of x minus 1 to the power 3 plus 2 the root of x minus 1, and then you say plus c. So this is the solution for this question for C. So we move on to D. Yeah, but I think these remaining questions are just almost the same as what we have done. So let me also do D, and I'll do E. The rest of the questions are just the same as what I've done so far. Actually, they have just repeated the same question, so I'll just do D, and then I'll do E, and probably even F. So D is integrate x plus 2 over the root of 2x minus 1, yeah, with respect to x. So again you do the same. Let me just demarcate this. Okay, again you do the same here, straightforward. You equate your u, you let your u to be equal to 2x minus 1, so that when you find your du dx you have 2, so that your dx will just be du over 2. And then here again you can make your x the subject of the formula. So when you make x the subject of a formula, you are going to have u plus 1 over 2 like that. Yeah, so here's just a matter of now. So this is just equivalent to, or let me just start writing from the top there. Yeah. Okay, so we can see that our x is equal to this, then our dx is equal to that, and then our u is equal to that. So it's just a matter of replacing now in the integral there. So where there's x, we put this part this side. Where there's x, we put this, and then where there's u, we put that. Where there's 2x minus 1, we put u. So we're going to have the integral of where there's x, we put u plus 1, and then over 2, then we still have plus 2 there on top, and then the denominator there will just be equal to the root of u. Then we're saying du, where there's dx, we put du over 2. So I'm multiplying this, so we can simplify. We can see that this can be simplified before we even start integrating. So when you find the common denominator there, you discover that the common denominator will be 2, and then on the numerator, this 2 into 2, you're going to have 1 times u plus 1 to be u plus 1, then 1 into 2 is going to be 2, 2 times 2 there will be plus 4 like that, over 2, and of course this is going to be divided by 2u to the power half. Then we're trying to integrate this with respect to u. So what you do here again, you are going to have so this will be u plus 1 plus 4 is going to be u plus 5. So on top there we're going to have u plus 5, then over 2 u, or just over 2, and then we're multiplying this by u to the power negative over 2, and then over 2 again. We're multiplying this by u to the power negative half, then we're integrating it with respect to u. So here it's now straightforward. Yeah, we can just simplify it further before we even start integrating. So when you divide this by that, you're going to have okay, let me just write it here for simplicity's sake, 1 over 4, then the integral of, when you multiply this u to the power half times u, you get u to the power half. U to the power negative half times u, you get that. And then you have plus, you get 5 u to the power negative half. Then all these you're integrating them with respect to u. So here it's just a matter of now integrating. Of course this is negative, yeah, so it's just a matter of integrating. So when we integrate, we're going to have 1 over 4 open brackets. So you integrate that, you get when you add 1 to half, you're going to get u to the power 3 over 2, and then over 3 over 2 like that, and then plus 5 over, when you add negative half plus 1, you get positive half as your new power. So we're going to have positive half there as our new power. Then you close the brackets, and of course don't forget to add c. So here what you do, you can see that these are multiplying. So in short, you can simplify this by writing, when you divide this into that and this into that, you get 1 over, in short, we're going to get this as your final solution, 3 over 2, and then the root of u to the power 3, then plus, you get 5 over 2 in the root of u, and then plus c. So here now, to write the finest answer here, it will now be just the matter of replacing where there's u. Remember that our u was 2x minus 1, you put your u there. So you're going to have 3 over 2, and then the root of 2x minus 1, root of 2x minus 1, then raised to power 3, and then plus 5 over 2, you have 2x minus 1, yeah, of course this is supposed to be the root of 2x minus 1, then plus c. So this is now the integral of this question here. So this is what you have. So f is saying, so f is x, then open brackets you have x plus 6, then everything divided by x plus 3 like that. Then you do this to the power 3, then this will be dx. So to differentiate this, you make your u as that. So you let u be equal to x plus 3, so that when you make x the subject, you have u minus 3 as your x. Then you find du dx, there you get your solution to be 1, meaning your dx will be nothing but equal to du. So when you are replacing this now, you just have to replace them there according to their corresponding function. So where there's x, I'm putting u minus 3. So I'm going to have u minus 3 there. I'm going to have the integral of u minus 3 multiplied by u minus 3 plus 6, everything divided by u to the power 3. Then this side I'm putting the u. So you can see here that this is now straightforward. We're just going to have the integral of u minus 3, then you have also the integral of u, when you add the 2 you get positive 3, so u plus 3, which is over u to the power 3 du. So you can see that this is the difference of two squares. So in short, you can just say u squared minus 3 squared over, oh sorry, this 3 squared over u to the power 3 du, which can be simplified as the integral of, when you divide u squared divided by u to the power 3, you just get 1 over u minus 3 squared is 9 over u to the power 3. So integrating this with respect to u. This is now straightforward. When you integrate 1 over u, you get ln u. When you integrate this negative, okay, let me just integrate it first here, or else I just wanted to show you how to integrate it, but let me just finish it up. So this is the integral of 1 over u, and then minus 9 over 3 squared. So I'm having the integral of 1 over u minus 9 u to the power negative 3, which is just the same as this. You can see. Then I'm integrating everything here with respect to u. So the integral of 1 over u there gives me the ln of u. Of course, this is supposed to be in absolute value brackets. So here, when you integrate that, you're going to get negative 9. When you add 1 to negative 3 there, you get negative 2. Then divide by the new power there, which is negative 2, and then you get your solution to be, you also add your constant there. So here the solution now will just be equal to the ln of u, and then this will be plus 9 over 2 u squared plus c. So this is going to be your answer, but don't forget to replace your u with x plus 3. So in short, your final answer, where there is u, put x plus 3. That is going to be your final answer. So let's proceed now to the next question. Of course, the remaining questions are straightforward on question 3. So if you have any questions on question 3, or more especially on the questions that I've left, you can easily, actually they've just repeated the same questions that we have already solved. So if you have any questions on this one, as you are solving, you encounter any question, or you find one question challenging, you can easily capture it, or maybe solve it on a paper and try to show me on WhatsApp. I'll tell you whether you've gotten it correct or wrong. So let's see now how we solve question 3. Question 3 is saying use partial fractions to find the indefinite integrals. So we're going to be using partial fractions. I guess you did partial fractions last semester, so I think this question is not going to be difficult for you. So we're now doing question 4. This is question 4 on calculus, and then we're using partial fractions to find the solutions of these questions. So we're going to have the integral of 3 over x plus 2, and then you have x minus 2 there. So how do you go about with these questions? Then you have dx there. So partial fractions, so you know that this, using partial fractions, let me just write it separate here. Using partial fractions, this can be written as, so this can be written as 3 over, this can be written as a, this is a over x plus 2 plus, and then you have b over x minus 2. So so here we can now resolve this into partial fraction. How do we resolve that? You remember in partial fractions what we did, so you express this part as a single fraction as well. So we're going to have this x plus 2, x minus 2. So this is equal to, so when you're resolving this as a single fraction, you find the common denominator, which is just going to be x plus 2 then you have x minus 2 there, and then you say x plus 2 into this denominator there, you get x minus 2. X minus 2 times a, you get a x minus 2, like that. Then you get plus, and then this side, this into that, you get x plus 2 times b, so meaning you get bx plus 2, like that. So what you do here next will be, it's going to be like this. So since the denominators are the same, it means that the numerators are also the same. They are also equal. So in short, what I'm trying to say is I'm going to equate 3 to everything there on top. So when I multiply a times x there, I'm getting a x. Then a times negative 2, I'm getting negative 2a. And then positive b plus x, I'm getting bx. And then b times 2, I'm getting positive 2b, like that. So in short, I'm going to get the coefficients of x this side and equate them to the coefficients of x to the other side of the equal sign. And then I'm also going to get the constants this side, equate them to the constants that side. So the coefficients of x this side we don't have, so I'll write 0. So 0 is equal to, and then the coefficient of x on this other side is going to be equal to a plus 2b, like that. So just from this you can see that your is just equal to negative 2b. Yeah, you can see, no, sorry. So b times x, the coefficient of x, so you can see that a plus b, not 2, because when you get the coefficient of x there, it's just b, here it's just a, so this is a plus b, so meaning your a is just negative b. Then you can proceed now to finding to looking at the coefficient, the constants. So the constant there we have 3, and then this other side we have our constants, which are negative 2a, and then we have positive 2b. So I know that where there's a, I can put negative b, so I'm going to have 3 is equal to negative 2, then where there's a, I put negative b, then plus 2b. So this is going to be 3 being equal to negative 2 times negative b. I'm going to get 2b, and then plus 2b. So meaning this side I'm going to have 4b being equal to 3. So meaning the value of b will just be nothing but equal to 3 over, it's going to be 3 over 4. So meaning my a from this point there where I said a is just negative 2, negative b. So meaning my a will just be equal to negative 3 over 4. So negative 3 over 4 is going to be my a. So from there I think I can also, from this I think I can do that. I can demarcate. So having found my a and my b, I'm just going to replace them there to find my partial fraction. So I'm going to have the integral now of while this a, I'm putting negative 3 over 4. So I'm going to have negative 3 over 4 and as my a, and then of course my partial there, my fraction there is going to be like that. And then so this is going to be positive 3 over 4. Then the denominator of course there will be x minus 2, like that. So this would be dx. So to integrate this, it's now easier to integrate. So I'm going to have my final answers to be equal to, when I integrate negative 3 over 4 over this, I'm just going to get negative 3 over 4 ln x plus 2. Yeah, and then this is going to be plus 3 over 4 ln x minus 2, like that. Then of course don't forget to put your constant c. Yeah, so this is the solution. This is the solution for the first question on question 4. Yeah, it's the solution for A. So let's also solve question B. So B, they are saying we also have to use partial fractions. So this is going to be 2x plus 2, everything divided by x squared minus 2x, then plus 1. We are differentiating this with respect to x. So this can also be written in partial fractions as the integral of before you do that, first you can try to factorize the denominator. This one, you try to factorize the denominator and then see the factors that you're going to find there. So when you factorize the denominator there, first let me write the numerator. When you factorize the denominator, you are going to have x minus 1, then you also have x minus 1, like that, and then dx. So we can now write this in partial fractions, which gives 2x plus 2 over x minus 1, x minus 1. So you can see that the denominator there has repeated functions. So we are going to have something like this: a over x minus 1 and then plus b over x minus 1 squared, since they are repeating. So there's just a matter of simplifying this. So when we simplify this, we're going to have 2x plus 2 being equal to, we're going to get a, then when you simplify this, you're going to get x squared, then you get negative 2x plus 1, like that, then plus b x minus 1. So here is just a matter of now comparing the terms. This side, the term which has x squared, or let's take first the terms which we have. So the constants here we have 2, then this side the constants we have a and negative b. Let us also now, in short, here a is just equal to 2 plus b. Let us also now compare the terms with x. So we have 2 this side, then the term with x this side we have negative 2a. We also have b, so it's going to be plus b. So while there's a, I can replace with 2 plus b. So I'm going to have 2 being equal to negative 2, and then we have 2, this is 2 plus b, like that, and then plus b. So when you simplify that, you discover that you have negative 4, and then negative 2b plus b, meaning your b is just going to be equal to, so when you add the negative 2b plus b, you get negative b, and then this negative 4, when taken to the other side, you get positive 6, and so meaning your b is just going to be negative 6. And then apart from that, you also need to find a. So a is just going to be equal to, you get this, where there's b you put a, so a is just going to be equal to 2 minus 6. So A is just going to be equal to negative 4. So we can now replace our values of A and B where they are, where in the main expression there. So when you replace, you are going to get let me just demarcate. Okay, so when I replace, I'm going to get the integral of, while there is A, I'm putting negative 4, so I'm going to have negative 4 over x minus 1, then plus B is B is negative 6, so I'm going to have minus instead of plus. This is minus 6, minus 6 over x minus 1 squared. So it's easier now to integrate this, because when you integrate the first part there, of course you get the ln of x minus, actually it's supposed to be negative ln. You're going to get negative ln, sorry, not negative ln, it's going to be negative 4 ln x minus 1. Then this side you have negative 6, 6, sorry, it's going to be a positive here. So you can use substitution to integrate this. You're going to get 6 over u, and sorry, not 6 over u, it's going to be 6 over x minus 1, then plus c there. Don't forget to put your c. So this is going to be your solution. We proceed to the second last question there. So the second last question is going to be, is this, which is x squared plus 1, and then everything divided by x squared plus 2 x minus 3. Then dx. So I think solving these questions are straightforward. You guys can do this. So even this one is just a matter of simplifying. You simplify the denominator, you express it in partial fractions, and then integrate. Same applies to d. It's also straightforward. So I think you guys, I'm giving you work on this one. So make sure that you solve this as well, you guys. Solve it, then submit your solutions. I want to check your solutions. Just make sure that you submit. So submit question 4C and question 4D, so that I know whether you have understood or not. I want you to submit question 4C and question 4D, even questions on question 3 which I did not answer. I want to see you guys answer these questions. All right.